start with, I like to tell you some basic things about the batteries we're using now. Assuming that I can earn a lot of money, so about 2 or 3 years later, I should be able to buy the Tesla Model S, which is using lithium-ion battery. Yes. And now a lot of researchers, they are doing a lot of research. A lot of researchers as well as a lot of research assistants like me, we're doing a lot of research on lithium-ion battery, which could be the next generation of the battery for electric vehicles. And usually such kind of batteries are much lighter and much more energy efficient. And it's what's happening in this battery. It's kind of messy, but don't worry, I'll tell you everything. Here is the anode, here's the cathode, and it's filled with electrolyte, which is organic, so that it won't react with ions released. And anode, it will have some blah 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 blah, and also some lithium metal, which will be ionized into the lithium ion as well as the electrons when reacting. And when after ionization, they will diffuse into the electrolyte and diffuse to the cathode finally. And at cathode, the oxygen will also be attracted to the cathode, and the oxygen, they will react with the electrons and lithium ions they meet, and it will finally react into the lithium peroxide, which is, you can see the circle participates here. And because usually the lithium peroxide, they are usually at a very low energy state, they are usually quite stable. And also the electrons will continue to go through in this direction, and which we can, so that we can get current. And that's how we call it discharging. But usually after 3 or 4 hours driving, we usually run out of power. So we want to charge our electric vehicles. So we are going to compare. We want to provide very high voltage so that the electrons will go in the reverse direction. So the electrons will come from here to here and have some reverse process happen. And the lithium peroxide should be decomposing to the lithium ion some electrons, and finally the participates will just go away. And that's some theoretical imaginations, not imagination actually, but some speculations for such a battery, and that's why we are working on it. And in this project, we are specifically working on the configuration of carbon fiber and try to see, okay, how should we put this carbon fiber so that we can maximize the performance of such a lithium battery. So, as what I told you before, such kind of battery sounds very perfect, and it sounds like, okay, it can work very well. But actually, so when we come into the middle of this summer, we are always working on this carbon fiber stuff. But finally, we realized one thing is that, okay, the electric conductivity of the lithium peroxide is very low, so it will actually be very difficult for such kind of precipitate to decompose. So it's very possible that there will be more and more electroperoxide here, and finally they will just crop the cathode here, and finally the battery will just go dead very quickly. And a very obvious evidence is that when we are trying to, when the scientists try to recreate the process of the nucleation, they ignored something inside. I can't tell you now, but I will show you later. And so, with this project, we changed our direction in the half part of our project. We finally planned to prove that, okay, such kind of battery may not work. It's actually very sad to say so, but of course it's just our guess, but it's very possible. And we are trying to work very prudent so that it's a very good, we try to work very prudent, so we will show some the real result to other researchers. So maybe there will now be more researches on the lithium-ion battery. But of course, we're still working on it, and let's see what will happen.